So let us start with the next topic of syllabus, conical pendulum. What exactly conical pendulum? It is a small heavy mass attached to the rigid support by a string, inextensible string, and when we move that bob to move in a horizontal circle like this, then that is said to be conical pendulum. If we move it to one side and leave it, it will perform to and fro type of motion. That is nothing but a simple pendulum that already we have learned in chapter oscillation. Now, what is the difference between simple and conical pendulum? Simple pendulum perform to and fro type of motion. Conical pendulum perform a circular horizontal motion along a circumference of a circle, and its string will make a cone. It will make a cone, ice cream cone like this, with an angle theta. Theta is said to be semi-vertical angle, half of the conical angle. Remaining half here, it is again theta. So total vertical angle will be twice of theta. So in this fashion, we have to see here what exactly conical pendulum means. What heavy mass or heavy sphere is attached to the end of the string, inextensible string, tied to rigid support, and when we give it to oscillation such that the bob of simple conical pendulum perform a horizontal circular motion, and the string trace out the conical shape area with semi-vertical angle theta, then resultant thing is said to be conical pendulum. Now in this conical pendulum, suppose at one instant particle comes at point B, what are the forces acting on this? Same thing we have done initially also. The first force act due to mass in downward direction, and second force is due to T0, tension in the string T0 directed toward the rigid support. So this T0 directed toward the rigid support. C is the center of the horizontal circular path in which the pendulum or this bob is moving. Horizontal circular path, center is C. The length of simple pendulum is suppose capital L. Suppose the length of from rigid support to this place or this to this place, the length is capital L. That is said to be length of conical pendulum. Now when this conical pendulum perform a motion, let us divide this tension T0 into two components. Resolve it, resolution of component. Vertical component is T0 cos theta, horizontal component is T0 sin theta. Now this C is the center of this horizontal circle whose radius is small r. Now this T0 cos theta balances the force mg, and this T0 sin theta provide a necessary centripetal force required for this horizontal circular motion. So again here we can write two equations. First of all, this T0 sin theta, I will write here, it is T0 sin of theta. It will provide what? Necessary centripetal force mr omega square equal to mv square by r. In your book they have taken mr omega square, so you can take both also. Just according to book will go, it is mr omega square, equation 1. Upper just toward the center, that is nothing but to provide the necessary centripetal force. Now the second equation, upward force equal to downward force. So T0 cos of theta equal to mg, equation 2. Divide equation 1 by 2. Let us divide equation 1 by equation 2. What we get here? T0 sin theta divided by T0 cos theta. Sin divided by cos becomes tan theta. T0 cancelled out. So tan of theta equal to what? M get cancelled out. R omega square divided by mg. R omega square divided by mg. So we get this equation, r omega square divided by mg, or we can just divide them and don't do any calculations, just divide them. You can write just T0 cancelled out, sin theta divided by cos theta. According to book sin theta divided by cos theta, get cancelled out, equal to mr omega square divided by mg. Get cancelled out. Now move this g to this side, r to this side. Just you can write omega square equal to g sin of theta. This g goes to numerator, divided by r cos theta. R into cos theta and denominator, that is omega square. Now look at diagram. Look at the diagram. Suppose I have made this triangle like this. Sin theta. What is sin theta? Opposite side divided by hypotenuse. Opposite side is what? R. So we can write here sin of theta, opposite side R, divided by hypotenuse is nothing but L. So this implies that what is the value of R? equal to L into sine of theta. Put this value of R from here to here, this equation. Okay, by Pythagoras, the simple trigonometric formula, sine theta, opposite side divided by hypotenuse, R by L. So R equal to L sine theta. Put it here now. We can write this as G sine of theta. Value of R is L sine theta into cos theta as it is. Sine theta cancelled out. So what we get here? G divided by L sine theta, and that is nothing but omega square equal to G divided by L cos theta, not a sine theta, it is cos theta, no? So it is L into cos theta, that is nothing but omega. But we know what is omega? 2 pi by t. So you can write the same here somewhere. I will write here omega equal to 2 pi by t equal to, here is omega square. So omega is what? Square root of this, equal to square root of G divided by L cos theta. That is omega equal to 2 pi by t. Omega equal to 2 pi by t, and that is equal to square root of G divided by L cos theta. That is equation 1.7. Above the equation 1.7, that topic is. Now here we want to find out the value of t. Suppose we want to find out value of time period. Move this t here, omega here. So t equal to what? 2 pi square root of L cos theta divided by G, because omega comes in downward, 1 by omega, this goes upward, this goes downward. So we get this as t equal to 2 pi L cos theta divided by G, and this is the equation for time period of conical pendulum. Once you know the time period, you can find a frequency n equal to 1 by t equal to 1 divided by 2 pi square root of G divided by L cos theta. So this is the equation for frequency. This is the equation for time period of conical pendulum. In both the equation, 2 pi is constant, L is constant, G is constant. 2 pi constant, G, L constant. Theta is varying. Time period varies with a semi-vertical angle theta, as well as frequency also varies with a semi-vertical angle theta. So this is nothing but what? Just we have seen the conical pendulum, and we have derived the equation for time period of conical pendulum and frequency of conical pendulum. Same equation we have derived for simple pendulum also, if you remember. It is 2 pi square root of L by G if theta is very small. Here cos theta comes. That is the difference between time period of simple pendulum and conical pendulum. Let's go further. Just there is one equation just at the last of this topic. They have just mentioned the total forces equal to T0 sine theta equal to mr omega square. So in your book there are two diagrams they have given. The 1.9a I have drawn it here. 1.9a. 1.9b. What is the difference there? Just they have mentioned here it is mr omega square moving away. Mr omega square. So this is centrifugal force, and this is centripetal. This is centrifugal force, and this is the second figure 1.9b, that is for non-inertial frame of reference. 1.9a without this component, inertial frame of reference. But remember, in both the cases there must be centrifugal force, because centripetal and centrifugal force exist at the same time whenever a particle performs a circular motion. Below that there is one topic, do you know? Under this topic, just try to find out the value of tension in the string T0. Tension in the string T0 they have find out, and from this second equation they have find out tension in the string T0 if you want to find here. So you can write this T0 equal to mg divided by cos theta from equation 2. From equation 2. Similarly, from 1 you can find out T0 equal to mr omega square divided by sin theta. T0 equal to mg divided by cos theta from equation 2. Similarly, from 1 you can find out T0 equal to mr omega square divided by sin theta. So these are nothing but what? Conical pendulum. Below that there is a green shape is there. They have mentioned do you know. Just try to read this. It's a little bit important to understand. Let's go further. Vertical circular motion. I think it is better to start vertical circular motion in next video. So students, watch my video. While watching, put your textbook in front of you, and once you understand, just see my video, try to understand it, then you read the same topic from the book, you get a better understanding. So let's see you for next video tomorrow. Thank you.